So lately I've been working on building this decision-making matrix calculator, which is a simple decision-making tool that got introduced to me by the book Millionaire Fastlane written by MJ DeMarco. And the usage of this decision-making matrix is very simple. So let's say that you have to make a decision to pick a choice among a plethora of different options and you're having a hard time to pick the most optimal one. In those cases, it's a perfect use case for a decision-making matrix like this. So for the sake of demonstration, let's try to come up with some very trivia options that we ought to pick the best option from. So let's say that we're hungry and we're trying to make a decision between ordering pizza versus having some food box that we have already ordered. So option 2 is going to be food box. How you would make a decision out of these two options is that you're going to come up with a set of criteria that matter to you, and by which you're going to be judging these two options. So for instance, we can have a criteria called taste. How does the food taste? And for our second criterion, we can judge the two different options by its cost. And for the sake of demonstration, let's have another criterion that we're going to be judging these two options by, which is going to be healthiness. And after we have came up with these criteria, for each criterion, for each category, we're going to give it a relative scale of weight. This metric is going to determine how important this category means to you when it comes to judging these two options. So for example, for me, taste matters a lot to me. So from 1 to 10, taste is going to be a 10 for me, definitely be a 10 for me. And for cost, we can say this is only a decision for one meal, so cost really doesn't matter that much. It's not that big of a deal. So we're going to say for cost, we're going to give it a number of 6. Now healthiness, for me personally, is going to matter more than cost. And one meal is enough to throw off your diet. If you're having some junk food, it can cause some serious damage. So for healthiness, I'm going to personally give it an 8. And now that we have our set of criteria and how much each category matters to us by weight, we're going to assess these two options by each of the criterion. So ordering pizza, I'm going to say I love pizza. So for pizza, I'm going to give it a 9. Keep in mind, these scores need also to be out of 10. In food box, I hate to say it, but it doesn't taste that tasty. I'm going to give it a 6. And in terms of cost, ordering pizza, you would have to pay for service fee. You would need to tip the courier. So for the costs, I'm probably going to give it a 6. And in terms of food box, it's existing. We already have it in the fridge. So it's going to be a 10. Now, when it comes to healthiness, pizza is going to have a score of 6 as well. And for the food box, we're going to give it an 8. It's very healthy. And after we have punched in all of the scores for each of the options per its criterion, per its category, we can calculate the sum of all these scores. How you're going to do it is, for each score, you're going to time it by its weight. So for the ordering pizza column, it's going to be 9 times 10, 6 times 6, plus 6 times 8. And if you sum those numbers up, it's going to come down to 174. Versus for food box, it has a relatively low score for the taste. However, it's unbeatable when it comes to cost and healthiness. Therefore, it comes down to a sum of 184. And rationally, no matter how addicted to pizza you are, once you've labeled all these categories that matter to you out, and you have subjectively given each option a relative score, hopefully by looking at the results, you're going to see which one is the superior option. In this case, for this meal, we're going to be having our existing food box. So that's the motivation for me to create this little web app, so that I can have this tool handy when I need to make a difficult decision. And you can say, oh, you can achieve a similar result by creating a template in Google Sheets or Excel spreadsheet. But I would argue if you have this little web app handy, it's more convenient to just punch in the number this way. And in addition to this, you can do a lot of other things. You can persist all of your past matrices in a database, and over time you can compare and contrast and possibly glean some insights from all the past data. You just have way more options versus having to load up a template and create a new file each time you have to make a decision. So with that said, another functionality that I really wanted to implement into this tool is that I want the column headers and the rows to be able to be dragged and dropped if you want to swap them around. So what I meant by that is that as you can see, if you drag the ordering pizza onto the food box option, you can swap the two columns, and all of the corresponding scores and the sums, they rearrange appropriately. And same thing happens when you drag and drop the rows onto each other. It's going to displace the thing that you want to replace with, and it's going to reorder all of the scores accordingly. So that's something that I implemented by using the Angular drag and drop CDK. Originally, I wanted to lay out this tabular data with mat table. However, I ended up using the vanilla HTML table elements to build out this prototype because it's just way more flexible to work with the HTML table elements versus when I was working with a mat table. Mat table, it gives you a very consistent styling, and you can implement the mat sort and pagination in the Angular fashion, but I found it's not very flexible, especially when I'm trying to build out this prototype that has a lot of customized functionalities. However, I experimented with the mat table, and I tried to implement the drag and drop the drag CDK into the mat table, and I was able to achieve this column header swapping and row swapping functionality. And that was the foundation that got me to implement the same kind of techniques when it comes to drag and drop column headers and rows into the HTML table elements. So I thought I would make a video to share with you guys how to implement the drag CDK into your mat table. And if we take a look at the code over here, in the table element, we have a CDK drop list group, and this is going to be the parent container that is holding two CDK drop list directives. One is holding all of the table header columns. These are the columns. And another CDK drop list directive is wrapped around the mat row elements, which are these horizontal row guys. And if you look at some of the existing solutions that achieve similar things, namely adding the CDK drag and drop functionalities to the mat table, you would find they typically do something like labeling the mat header cell element to be CDK drag and CDK drop list at the same time, so that these guys are draggable, and they're also containers that can detect when things are being dragged into them, so that when something is dragged into them, they can, based on they can fire if you have a CDK drop list directive, there's going to be a event handler called CDK drag list dropped, this method, and you can do things in this method to change the data binding of the header column this way. However, I found in the latest Angular CDK, namely I'm using the latest Angular major version, which is version 16. After you have labeled an element to be CDK drop list and CDK drag at the same time, it doesn't throw any error. However, this method, the CDK drop list dropped method, is not going to fire. So the existing solution for this kind of functionality is no longer doable. You cannot have this element to be CDK drag and CDK drop list at the same time. So I elected to create this artificial div parent container element to wrap around these column elements so that you can achieve the drag and drop this way. However, if you do it this way, the CDK drop list dropped event listener, it's not going to behave correctly. If you do it this way, I can quickly show you. Let's say we create a new method called drop list dropped. Okay, it looks like I already have it defined. So test method. Do I have that? Okay. And we just console log the event. It's not going to have a payload. And okay, we need to loosen the type a little bit. So if we look at the console, you can see that whenever the CDK drop list dropped method fires, the previous index and current index is always 0. It's essentially useless because it doesn't contain any information that we would need to swap these guys around in the data binding, namely this array. So my solution is to temporarily, wait, let me disable this event listener real quick. My method is to utilize the CDK drag started method and temporarily cache the index as a variable in your TS file, and that is going to be previous column index. So whenever we initiate a drag event, we're going to, you see this drag started event, we cache this index in memory. And whenever you drag something, whenever you drag a column onto another column, notice I have a mouse up event listener listening for your mouse being released on this thing. And if we look at the implementation of this method, it's going to first check if the previous column index variable is undefined. If it's undefined, it means that you're just releasing your mouse on top of it. There's no column header being dragged onto it, so it's not going to fire these procedures. However, if you already have a previous column's index number cached in memory, it's going to first swap items in your columns array. It's going to swap them around by using the move item in array method, which is provided for us in the same CDK, in the same drag and drop CDK. And how it's going to shift things around is that it's going to shift from this position. The second index is the from position, and the last argument is the to position, which is provided in the mouse up method. So this mouse up, let's say that we're dragging this column onto the weight column. When you release the mouse on this weight column, it's going to send the index of the weight column as the second argument into the drop list dropped method, so that it's going to know, oh, we're shifting this, we're swapping things from this index to this index in this data binding, which is the column headers. And after that, so that was our little walkthrough. The code is very compact. There's not a whole lot of logic in the TS file. So what I'm going to do is I'm going to quickly clean up the things that I did to achieve the drag and drop and try to recreate the logic with you guys. So I'm going to do a jump cut right here and show you the cleaned up version where it's just the vanilla mat table. Okay, now that we have cleaned up the code, you can see that it's just the default mat table. There's no drag and drop going on here. And we're going to build out the drag and drop functionality from scratch. We have already imported the necessary module, method, and directives. It's going to be CDK drag drop, CDK drag start, CDK drop list, and move item in array. And in your module file, you would need to import this drag drop module, which is coming from the @angular/cdk/drag drop. And let's now move over to the template file and start implementing the drag drop feature. And the first thing we're going to do is that we're going to add the drag drop CDK drag directive to the mat header cell so that these guys can be dragged around. But as you can see, we don't have a container wrapping them around, so right now they're acting kind of unruly. You can just drag them anywhere and drop them and leave them there. It's not a very desired behavior. So the next thing we're going to do is we're going to create a new div, wrap it around the mat header cell, and add the CDK drop list directive onto it. And in addition to that, we can specify the orientation of the drag movement. And to do that, we're going to add the CDK drop list orientation directive, and we're going to specify that we would want these headers to be dragged horizontally. And with those in place, we can see we can effectively drag the headers. However, because we have not changed the data binding yet, so we're not seeing the column header swapping behavior. And before we would do that, we would add some minor styling changes. And let's add the CDK drag lock axis directive and lock it to the x-axis. So this time around, you can see these guys can only be dragged horizontally. They can only be dragged along the x-axis. And now let's go about implementing the column swapping data binding behavior. And to do that, we're going to, like we have already mentioned in the brief walkthrough section, we're going to utilize the CDK drag started event handler. And we're going to implement our own method for that. Let's call it drag started. And we're going to pass in the event, which is always going to be the first argument, and the index, which is the index of the column in the data array. And it's prompting us that this method hasn't been implemented. We're going to very quickly create it, and the first argument is going to be the event, and we only need the second argument, which is the index. To do that, we're going to cache it in a global variable. Let's call it previous column header index, IDX. It's going to be of type number. And whenever this method gets called, we just cache the index in this variable. And to address this error, we're going to use the assertive operator. And like we have talked before, to achieve the column swapping, we need to implement a mouse up event listener so that these guys know when something is being dragged on top of them and the mouse is being released, we swap these guys. So we're going to add another event listener, which is mouse up. Event handler And first argument is always going to be event. Second argument is the index. Let the IDE create the boilerplate for the method. And in this case, we're going to start the data binding changes. So we're going to check if the previous column header IDX, we're going to check if this thing is undefined. Or better yet, let's check if this variable is truthy. And if it's truthy, means that we're having something being dragged onto the element that triggered the mouse up event handler. So we're going to use the move item in array method, and the data binding is going to be this dot columns, and the from index is going to be this dot previously header IDX, and this and the last argument is going to be the index, this guy. And after we have done that, we're going to use the helper method to reshuffle the column headers that are going to be displayed in the DOM. And after we have changed the data binding, we better we better override this variable to be undefined, so that we can have we can achieve the okay. So it's saying this thing. Let's expand the type so that it accepts null. And the reason why we're resetting this variable to be null is that we want to achieve the function out to achieve the use case where if you're not dragging anything onto it and you're just blindly releasing the mouse, it's not going to execute this block. And now that we have done that, if you drag a column header onto another one, you're going to see the data binding getting swapped around. And now let's try to do the same thing with the rows in the table. Again, first thing we're going to do is we're going to create a container div, give it the CDK drop list directive, and for this orientation it's going to be vertical. And for the mat row elements, we're going to do the CDK drag so that they can be dragged around. And let's experiment with the CDK drag lock axis. Why? So So now ideally they can only be dragged vertically. But notice the data binding is not being updated. And let's implement the same strategy. Remember, we are going to listen for the CDK drag started event, and let's create a brand new method to handle this event. Let's call it row drag started. First argument is going to be the event, and let's grab the index for that row. The index is already being defined here, so it's J. So we pop J in there. Let the IDE create a boilerplate for us. And yeah. However, in this case, we don't want to cache the J in the previous column header IDX. We would need a brand new variable for that. Let's go to this part and rename it to be row IDX. And update the code here, so it's going to be update the code here, so it's going to be this dot previous row IDX. And again, we would need the mouse up event listener to listen for the mouse up event. And create a brand new method to handle the event. Row mouse up event handler. And the IDX, the index is going to be J as well. Create a boilerplate for that. J is going to be number. And again, we can just reuse this piece of code here. And if you want to really optimize the code here, I guess you can generalize the event handler so that you have less code, and these guys would be just calling one generalized function, and you can use some extra variables, some flags to differentiate the behavior between the column swapping and the row swapping. But for the sake of demonstration, we are just taking a shortcut and defining different methods to handle different events. To handle different events. So we are going to check if previous row IDX is truthy, and if it is, we're going to be swapping them around, and this helper method doesn't need to be invoked. Previous row IDX needs to be null. And if we run the code again, okay. If you run the code again, okay, the data binding doesn't get updated. I think it's because we need to refresh the table, the data source, so that MetTable knows we have done something to the data binding. And I would use the view child decorator, pass in the MetTable. It's going to be public. MetTable, yeah, and whatever. And specify this guy's my table. And in the code, after we have done all of these things, we're going to call the render rows method on the my table element, essentially on the table element, to let it know that the data source has gone through some changes. Now we want to re-render the table again. Now that, okay, what's this? To fix that, we're gonna use the assertive operator. And now when we drag the tables around, okay, so the problem is the data binding is not, we're doing the wrong thing to the data binding. This state is holding the data for the column header, whereas the actual data that we would need is from these guys. It's from the element underscore data array. So we need to update this argument to use the correct data binding. Element data. Now the rows are being properly swapped. So okay, so that's how you would add the CDK drag into your mat table. I think in the next video I would like to go through the things that I've learned from building this little tool here. How to grow the table dynamically. What's the general strategy of implementing the functionality of double clicking on a table cell and invoke this little input element to let the user change the value of this particular cell. And yeah, all right, I'll see you in the next video. Bye bye. Oh, I forgot to mention I'll be including the code that is hosted on my public GitHub in the description down below, so if you want to play around with it, feel free to do so. All right.